In this video, we're going to look at some examples where we are going to evaluate some limits using the limit rules that we found in our previous video that we discussed there. So let's look at this first example. Here we're taking the limit of 4x squared minus 2x plus 3 as our value of x is approaching 2. This is a polynomial, so with that polynomial, we can try direct substitution. We should be able to do direct substitution. So we can just replace that value of x with the value that the x is approaching. So we have 4 times 2 squared minus 2 times 2 plus 3. When we do that, we will get 16 minus 4 plus 3, which is 15. So we can just do that direct substitution. Here on the next one, we have the limit as x approaches -1 of the square root of x squared plus 3. And so this is equal to, using our limit rules, the limit as x approaches -1, the square root of the limit as x approaches -1 of x squared plus 3. So again, we can do that direct substitution. -1 squared plus 3. And we get a value of 2. Great. So here we are analytically evaluating these things. On the next one, we have a polynomial, a rational function, one polynomial divided by another. When we evaluate this limit, again, we can do direct substitution. So we have 0 squared minus 3 over 0 plus 2. So -3 halves. Perfect. If we have trig functions, that's not going to impact things as long as the value is in the domain of the function to begin with. So if we were to take the limit as x approaches pi of sine of x over 2 plus x squared minus 1, we can do direct substitution. So we have sine of pi over 2 plus pi squared minus 1. Sine of pi over 2 is 1. And so we get pi squared. And then finally, if we were to take the limit as x approaches pi over 3 of tangent squared of x, this is the limit as x approaches pi over 3 of tangent of x squared. So we have tangent of pi over 3, which is going to be squared. Tangent of pi over 3 is the square root of 3. And so when we square the square root of 3, we will end up with 3 itself. So all of these, we could do that direct substitution because we were dealing with functions that were continuous at those points, right? So they were continuous at 2, continuous at -1 here, it's continuous at 0, it's continuous at pi, it's continuous at pi over 3. Now up here on this third example, what would have happened if we had x approaching, instead of 0, x approaching -2? Well, if we had -2, we would get a 0 in the denominator. So direct substitution is not going to work there. But that doesn't mean that the limit does not exist. We just have to deal with it in a different manner. And we will look at that in the future. In the next video, we are going to look at how do we go about evaluating functions that are not continuous. We will see you there.